Hi fellas, just a short clip now on finding the distance between 2 points. Again, it should be revision from Year 9 Mathematics. I've subtitled it a variation on Pythagoras' theorem, and I want to show you why. Let's say I'm looking at these 2 points on the number plane, 1, 4 and 4, 8. Well, what I can do is form a right angle triangle between those 2 points, like so. There's my right angle there. And what you'll notice is that in the x direction I'm travelling 3 units, and in the y direction I'm travelling 4 units, 4 to 8. So that could be labelled 4. And we know from Pythagoras' theorem, let's call this A, or D in fact, let's call it D for distance. We know that D squared is equal to the square root, is equal to 3 squared plus 4 squared, and that's going to equal 9 plus 16, which equals 25 of course, and the square root of 25 is 5. Okay, so that's using Pythagoras' theorem. Now when it comes to coordinate geometry, we tend to take a bit of a shortcut, but it really is Pythagoras' theorem in disguise. And here's the formula we use. Essentially, the distance is going to equal the square root of the difference between the y coordinates, all squared, and the, plus the difference between the x coordinates, all squared. So it really is just Pythagoras' theorem. So in this case, to solve this problem, what we would do is just say that D is equal to, now the square root, big square root sign like so, y2 take y1, so it's a bit like working out the gradient, isn't it? You can go that take that, so it's the difference in the y coordinates, all squared, and then what you're going to do is add the difference in x coordinates, all squared. So substituting in, what do we get? We get 8 minus 4 all squared plus x2, well x2 is 4 minus 1 all squared, and it's going to work out to be the same answer as before. So 8 take 4 is 4, 4 squared is 16, plus 3 squared is 9, and therefore D equals the square root of 25, therefore D equals 5 what? 5 what? Yes, 5 units, isn't it? We can write U for units, so that's the answer to that one. Okay, this should be a fairly straightforward example. What is the difference between -2, 7 and 0, -3? Okay, so we've got our formula written down, so we just say, substituting the values in for y2, y1 and x2 and x1, we would get this, wouldn't we? It would be -3 minus 7 all squared plus the x values now 0 minus -2 all squared. So D equals, what does it equal here? It equals -10 all squared, which is 100, plus double negative there means a plus, so it's 2 squared, which is 4. So the distance here equals the square root of 104 units. Notice I haven't given a decimalised approximation. That's fine. You can leave it in third form. Of course, if the third can be simplified, and I don't think this one can be too easily, you should just leave it as it is. Okay, so the distance is the square root of 104 units. Okay, don't forget that symbol there if you don't have specific measurements. Well, here's a bit of a challenge. We've got 2 coordinates, x, 2 and 6, -3, such that the distance between them is 8 units. What is the value of x? Now, just pictorially, what's going on here is that we can plot 6, -3. We're not really required to solve this problem, but just to let you know visually what's going on. We know the y coordinate in this pair of coordinates is 2. So it's somewhere along this dotted line. All along here, y is equal to 2. So really what we're asking is what x coordinate will give us a distance of 8 between this point here and that line there. Okay, well, what you do always is start off with a formula, and the only formula we really know at this stage is our distance formula, like so, and what we do is we substitute whatever we can into our formula and something might just happen. So let's see, just write that down. Okay, well, we know the distance is 8, okay, so that we can say that 8 is equal to, now what are the y coordinates? Well, -3, take 2, all squared, that seems straightforward enough, plus 6 minus x, all squared. And our job, of course, is to find this value of x here. Okay, let's see what we can do. So therefore 8 equals the square root of, now that's going to come to 5, isn't it? -5 actually, but -5 all squared is 25, plus, now what we're going to have to do here is expand out the brackets and see what happens. So 6 squared is 36, minus twice the product of the inside term, so that's 12x, and plus the last term squared, isn't it? Now, what I can do here is, well, certainly add the 25 and the 36, and so I'll just move that up a bit, and say, therefore, 8 equals, that's 61, isn't it? Minus 12x plus x squared. Okay. Well, what I'd suggest we do now is probably square both sides, and that gets rid of this rather big square root sign, doesn't it? So I can square both sides. Okay, so let's do that. Therefore, therefore 64, so 8 squared 64, equals 61 minus 12x, that should have been, plus x squared. And you can probably see that we can take 61 from both sides, and we'd end up with x squared, and do a bit of rearranging, minus 12x plus 3, is it? No, it's minus 3, equals 0. Okay, now what we've got to do is solve a little quadratic. Okay, so now this one's not going to be too easy to solve using PSN. We can't do that. So what we'll use is the quadratic formula. Okay, so remember what that is? It goes like this. Well, lost you, come back. Okay, so now the quadratic formula goes like this. X equals minus b plus or minus the square root of b squared take 4ac. I hope you have all remembered that from last year, all over 2a. Okay, now remember, the coefficient of x squared is giving you the value of a, the coefficient of x is giving you the value of b, and the constant is c. Okay, alright, so substitute away we go, and we get, therefore, x equals minus b, so minus negative 12 is 12, plus or minus the square root of b squared, that's rather conveniently 144, minus 4ac. Now let's do this as quick as we can. 4ac, so 4 times 1 is 4, times negative 3 is negative 12. So I'm minusing a negative, so I've got to add 12, like so. All over 2a. Now a is equal to 1, so it's just over 2. Okay, let's see what that comes to. here we go. Therefore, x is equal to 12 plus or minus the square root of 156 over 2. Now in reality you probably want to use your calculator to work that out, but we can simplify it and leave our answer in third form if we like. 156, now 4 is a factor of 156, isn't it? So we can say that x is now equal to 12 plus or minus. Remember how we simplify thirds? 4 goes into that, 3 times, 3 left over, so 39, like that, over 2. And the square root of 4 is 2, so I can take that out, can't I? So what we get is this sort of thing. Therefore, x equals 12 plus or minus 2 square root 39. Square root of 39 cannot be simplified, can it? Over 2. And notice we can divide that by 2, that by 2, and that by 2 to get, x equals 6 plus or minus the square root of 39. Okay, now what that's telling us, gentlemen, is that there's two possible answers. X could equal 6 plus the square root of 39, so the square root of 39 is a bit more than 6, isn't it? Because 6 squared is 36, so a bit more than 12. Or x could be negative, in fact. X could be 6 minus the square root of 39, which would be negative 0 point something or other, wouldn't it? So I've got two possible answers, and that's perfectly acceptable. If you go back to your graph, don't know where that's gone. You can probably see here that my line could be somewhere out, my other point could be somewhere out there, out there. So if it was 6 plus the square root of 39, it would be somewhere out there, or it could be somewhere down here, right? Two possibilities, okay, and that's that problem, bit of a challenge. Finally, lads, try this one now. You might find a picture or a number plane representation of this might help get your head around it. Okay. Well, as I like to say, ciao bambini, and be nice to your teacher. Bye bye.